Hello, hello, hello. I hope you can hear. Okay, okay. So far we have been discussing about the module three. So here you can see you are having the problems to calculate the thickness of payments. So I have shared this problem answer on the Linux, and you can check it. Okay, so in these problems you can see that the values are not directly given. Some values are not directly given, but they are indirectly given, just like the uh, table, and from the table you have to draw the graph, and you have to find out the required CBR value. Or in some problems they are not directly given the effective CBR, so at that time you have to refer to the that clause 5.2 graph. So that is available in the 2012 IRC 37. Okay, so the 2012 IRC 37 is the uh, mostly asked IRC in the exam point of view. Okay, so at that time you have to refer to that IRC. So that 2012, in that 2012 you can see various graphs. So graphs showing the thickness of component layers. So you can use those graphs. So you need not go to the graph provided in the 2001 IRC. Okay, so you can go to 2001 also. Anyway, you will be provided with the required details in the question paper, because these IRCs are not allowed in the exam hall. Okay, IRCസിന്റെ അവസാനം നോക്കിക്കഴിഞ്ഞാൽ നമുക്ക് അതിൽ ഈവൻ സോൾവ് ചെയ്തിട്ടുള്ളത് വരെ കാണാൻ വേണ്ടി പറ്റും പ്രോബ്ലംസ്. സോ അങ്ങനെ ആയത് കൊണ്ട് അതിന് നമ്മുടെ എക്സാം ഹാളിലേക്ക് പെർമിറ്റഡ് അല്ല. സോ നിങ്ങൾ എന്ത് ചെയ്യുക, അത് സോൾവ് ചെയ്ത് നോക്കുക. സാമ്പിൾ കാൽക്കുലേഷൻസ് ഒക്കെ അതിനകത്ത് തന്നെ ഉണ്ട്. സോ യു ക്യാൻ calculate the values and you can check it. Okay, so if they have indirectly given the CBR values, then you have to find out it. Or sometimes they may have given two CBR values. So CBR value of the dense foundation and the dense soil foundation, and the CBR value of the bore soil. Okay, so at that time you have to find out the effective CBR from the graph. Okay, that clause 5.2 you can refer. And now let's discuss. Now I hope you can solve the problem. Have anyone solved it or got the answer? They can share it. Okay, നിങ്ങൾക്ക് ക്ലാസ് ടൈമിൽ കിട്ടുന്ന പ്രോബ്ലംസിന്റെ ആൻസർ ഷെയർ ചെയ്യാം. ബാക്കിയുള്ളവർ അത് കമ്പയർ ചെയ്തിട്ട് എന്തെങ്കിലും വേരിയേഷൻ വരുന്നുണ്ടെങ്കിൽ ചെയ്ത സ്റ്റെപ്സ് നമുക്ക് ഡിസ്കസ് ചെയ്യാം. സോ അതാണ് നമുക്ക് ഇങ്ങനെയുള്ള ക്ലാസ്സുകൾ കൊണ്ട് വേണ്ടുന്നത്. മനസ്സിലായില്ലേ? നമ്മളിപ്പോൾ വെറുതെ ഒരു പ്രോബ്ലം ജസ്റ്റ് ഒന്ന് സ്റ്റെപ്സ് എഴുതി അതിന്റെ ആൻസർ എഴുതി വെച്ചിട്ട് കാര്യമില്ല. ജസ്റ്റ് നിങ്ങൾ മെത്തേഡ് എങ്ങനെയാണെന്നും കൺസെപ്റ്റ് എന്താണെന്നും മനസ്സിലാക്കുക. അതല്ലേ, ബൈ ഷെയറിംഗ് ദ ആൻസേഴ്സ്. ഐ ഹോപ്പ് ഇറ്റ്സ് ഓഡിബിൾ ടു ഓൾ ഓഫ് യു. നിങ്ങൾക്ക് കേൾക്കാൻ പറ്റുന്നില്ലേ? നേരത്തെ കുറച്ച് നേരം അൺമ്യൂട്ടായി പോയിട്ടുണ്ടായിരുന്നു. സോറി, നേരത്തെ കുറച്ച് നേരം മ്യൂട്ടായി പോയിട്ടുണ്ടായിരുന്നു. ഇപ്പോൾ ഓക്കെ അല്ലേ? ഓക്കെ ഓക്കെ. സോ here that's all about the module 3, and in the module 3 you can see various theory portions also, just like the material testing, then quality control, and material properties. So all of this can be discussed, and these are also having sufficient weightage in the exam. So you should not avoid this. മനസ്സിലായില്ലേ? ഇത് അവോയ്ഡ് ചെയ്യാൻ പാടില്ല. ഇതിന് നല്ല രീതിയിൽ മാർക്ക് വരുന്നുണ്ട്. എസ്പെഷ്യലി തിയറി പോർഷന് നല്ല ഇമ്പോർട്ടൻസ് ഉണ്ട് ഇൻ ദ കേസ് ഓഫ് C308. മനസ്സിലായില്ലേ? C308 നല്ല ഇമ്പോർട്ടൻസോടെ നിങ്ങൾ തിയറി പഠിക്കുക. സോ ബൈ ഡെഫിനേഷൻ bitumen is a hydrocarbon material. So it is having an origin from the petroleum product. Okay, so it's a petroleum byproduct, and it is soluble in carbon disulfide, then carbon tetrachloride, benzene, etc. Okay, so once it is soluble in any of these materials, then these materials can be taken as a solvent. Okay, so solvent means if you are having that bitumen attached with your hands, then what you will do, you cannot wash it. You cannot wash it away using water, because in water it is not soluble. So you have to use either this carbon disulfide or carbon tetrachloride, etc., in order to wash away the bitumen that is sticked on your hand. Okay, so this is a properties that I have discussed yesterday. So I hope it will be familiar for you. That means hot bituminous mixing and cold bituminous mixing. In hot mixing, you have to increase the temperature so that the viscosity become somewhat workable. Okay, so the viscosity should be workable. Then only the bitumen can be poured easily from one bottle to the another bottle. Okay, so at that time only it gets the property to stick around the aggregates. So the thing that you should do in the mixing process is that you should heat the aggregate. Okay, once the aggregate gets heated, then it starts radiating that heat from its surface. Okay, so at that time, once the bitumen comes in contact with the surface, then that bitumen also gets that heat, and it simply get coated on the surface of the aggregate. So at that time, the temperature slowly gets decreased. So the thin coating become permanent, and if that aggregate is having that coating, then the individual aggregates will combine together, because all the aggregates are having that bituminous coating. Okay, in that way the aggregates get combined, and we will get a dense thick pavement layer. Okay, that is a process going on here. Either you can provide heat, or you can provide chemicals in order to make the bitumen viscous. We have already discussed it. Okay, so the temperature range is given as 130 to 175. Okay, I hope the mouse pointer is visible for you. Mouse pointer കാണാൻ പറ്റുന്നില്ലേ നിങ്ങൾക്ക്? അൺമ്യൂട്ട് ചെയ്തിട്ട് കമന്റ് ചെയ്താൽ കാണുന്നില്ലേ? ഇല്ലേ? Mouse pointer visible അല്ലേ? Okay, so so after that, we have to study the types, different types of bitumen, then different properties of bitumen, testing and grading. Okay, so it's a binder used in pavements. Okay, so it's the bitumen is mainly used, or the more percentage of bitumen is used at the top layer, because top layer is having two properties. The first property is it should be highly water packed. Okay, so it should be watertight, as well as it should be capable of preventing the wear and tear. Okay, so it should be sufficiently hard. So for that purpose, we use uh, more percentage of bitumen at the top layer. Okay, so in questions we can see, so in the mixed design problems, you can see the bituminous concrete is provided at the top, and there is a bituminous layer on the top of that bituminous concrete. Okay, so we know the different types of layers, just like if it is a the sub-base course, so the bottommost course, you know, that is the subgrade soil. So on the subgrade soil you can see the sub-base course. Okay, and on above that you can see the base course, and on above that you can see the surface course. Okay, so the surface course mainly consists of rich quantity of bitumen, because of the two reasons. Okay, the water tightness and the wear and tear. Okay, and below that you can see it's mostly composed of aggregates. Okay, and the lesser percentage of the bitumen will be used, because in bottom portions, you know, the load gets dispersed to a larger area, so it need not have that much binding property, because it is having large sized aggregates. Okay, we just want to place the aggregates in position, that's all. Okay, so for that purpose the bitumen contents can be decreased. Okay, so in the mixed design it will be available. So in mixed design you can reduce the binder content at the bottom layers, so that the payment will not get failed. So it is a byproduct from petroleum, and then we are comparing with the tar. Okay, we are comparing it with the tar, and we are having one more bituminous binder, which is, one more binder which is known as asphalt. Okay, asphalt can also be used, and we will study about asphalt during the next module. Okay, so it is used in surface course, and in base course also we can use. So these are the uses, and it can also be used as a water repellent. Okay, so in buildings and all, we can provide a coating or a course at the top of the plinth. Okay, at the top of the plinth, just below the walls, we can provide a coating, just in order to prevent the entry of moisture from the basement. Okay, from the basement the moisture will be arising due to capillarity. So in order to prevent the entry to the wall, you have to break the entry of the moisture by providing a watertight layer made of bitumen. Okay, so that's also a usage. Okay, so tar is having some limitations, just like it is a pollutant, then it shows poor adhesion. in the presence of water. Okay, so here you can see the grades of bitumen. We will give a detailed picture regarding the grades of bitumen because in the coming module also we have to study a grade of bitumen. So what is the grade of bitumen? So if you want to express the quality of bitumen, then there should be certain measurements, just like the grade. Okay, we know the grade of concrete. Okay, M20, M25 in that way. But in bitumen also you are having certain grades. Okay, for cement you can see different grades. Okay, so for concrete also you are having grades. In the same way, for the bitumen mix you are having the grade, as well as the bitumen is also having the grades. Okay, so how the grade are decided? Okay, so the grades are decided by conducting some quality tests. Okay, so these quality tests can be anything. In practice, we are having two quality tests in order to determine the grade of the bitumen. So they are the penetration test and the viscosity test. Okay, so the penetration graded bitumen are there in one side, and then the viscosity graded bitumens are there in the other side. Okay, so both these gradings are having its own advantages and limitations. Okay, once you decide the quality of the bitumen based only on the penetration test, then you are having the penetration graded bitumen. But the penetration test is not only will help you to predict all the properties of the bitumen, because it is having some limitations also. We can just categorize the bitumen on the basis of penetration only, and the remaining qualities cannot be determined by using the penetration test. Okay, so that is a disadvantage. Still you can grade the bitumens in the range of penetration test. Okay, so how we will categorize it based on the penetration test that we will discuss during the penetration testing classes. Okay, so okay, I will explain the penetration test just within 5 minutes. Okay, at that time we will discuss about the penetration grade, and once we discuss it, the viscosity test, at that time we will teach you how to do the viscosity grading. Okay, and in the next module we are having some another type of grading, and it is used in the super paves. Okay, we are having super pave mix design, just like the Marshall mix design. We are having super pave mix design, and it is it is having some advanced. It is an advanced thing. Then it is having some advantages over the remaining mix design, and at that time we are going for some another kind of grading. Okay, so that grading also will be studied in the coming module. Okay, the grading used in the super paves. Okay, so that is the pavement grade. Okay, so we are having penetration grade, viscous grade, and pavement grade. Okay, three types of grading in general. Okay, so that pavement grading is having some advancements over the two penetration and viscous grade bitumens. Okay, so here we are having different types of bitumen. Okay, you can see the types of paving grade bitumens. There are some modified bitumen, then cutback bitumen, bitumen emulsion. Okay, so modified bitumen means we are adding some additives, just like we are adding some additives to the concrete in order to improve the quality. Here we are directly adding it with the bitumen. Okay, some chemicals, so it will improve some physical qualities. Okay, so cutback bitumen means in order to increase the viscosity, so in order to make the bitumen more liquid. Okay, so in order to reduce the density, so for this purpose you are adding some chemicals, and once you add the chemical you need not heat that much. Okay, so that will provide some economy. Okay, so for that purpose you are having three types of cutback bitumen. Yesterday we have already discussed. So it is the rapid curing bitumen, and the slow curing bitumen, and the medium curing bitumen. So for all this purpose you have to use different chemicals, just like the kerosene. You can use kerosene, then you can use naphtha, so you can use benzene also. In that way you can use different things, just like just as solvents, but these are not solvents. These are just agents which are responsible for improving the viscosity of the bitumen. Okay, so these are the cutback bitumen. And bitumen emulsion means you are emulsifying the bitumen in a solvent. Okay, just like if you mix it with water, then what will happen? Small granules of bitumens will be suspended within the water. Okay, so that's all about the bituminous emulsion. So here you can see the cutback bitumen. I hope you are following. Okay, okay, നിങ്ങൾ അൺമ്യൂട്ട് ചെയ്തിട്ട് പറയണം കേട്ടോ, എന്തെങ്കിലും പറയാൻ വേണമെങ്കിൽ, അല്ലാതെ എനിക്ക് സ്ക്രീന് കാണാൻ വേണ്ടി പറ്റില്ല. ഓക്കെ അല്ലേ എവരി വൺ? Yes. So we are having cutback bitumen. And you can read it out. Okay, the solvents just like kerosene, then fuel oil, then hydrocarbons. You can use naphtha. So all of these are hydrocarbons only, and all of these are petroleum byproducts itself. Okay, so it is having rapid curing, medium curing, slow curing. Okay, slow curing SC. Okay, in your class note it's given in detail. Okay, so the different uses. So bitumen emulsion means it is dispersed and it will appear as globules or granules, okay, in the aqueous solution. So water can be used as the dispersing agent. Okay, so in an emulsion, you may have studied in detail about emulsions. So emulsion means there will be a dispersing agent and there will be a dispersed material. Okay, so just like in a solution you can see the solvent and the solute. Okay, here you can see a dispersing agent and a dispersed material. Okay, so here modified bitumens are available in order to improve the properties of the bitumen. Okay, just we can add different. Okay, here especially we are adding the materials just like rubber. Okay, we are having different kinds of rubbers, so we can add these rubbers and you can add plastic. So you may have heard about plastic rods. Plastic rod means in the bituminous mixing process we are just adding finely graded plastic. Okay, we first grade the plastic into very fine size. Okay, so and we heat it thoroughly. So once you heat it, it can be directly added to the bitumen so that it will improve the properties, and rubber can be added. So a lot of materials can be added just like this in order to make the bitumen modified. So it is having some advantages. So for this modified bitumens are these are having some advantages just like, okay, these are given in the class note. You can simply read it out and okay, you can read it out and you can find it. Okay, just wait 1 minute. The system will restart. ഓക്കെ, ഇതിൽ തിയറി പോർഷൻസ് നിങ്ങൾ പ്രോബ്ലംസ് നോക്കുക. അതിൽ നമ്മുടെ സ്റ്റെപ്സ് ടു ഡു ദ മിക്സ് ഡിസൈൻ ചോദിക്കാം. പിന്നെ എന്താണ് നമുക്ക് മിക്സ് ഡിസൈൻ്റെ പ്രോബ്ലം ഇതുവരെ ചോദിച്ചു കണ്ടില്ല. പിന്നെ ചോദിക്കാൻ ചാൻസ് ഉള്ളത് സ്റ്റെപ്സ് ടു കാൽക്കുലേറ്റ് ദ പേയ്മെന്റ് ലെയർ തിക്നെസ്. ഓക്കെ, ബേസ്ഡ് ഓൺ IRC 2001 ആണെങ്കിലും 2012 ആണെങ്കിലും നിങ്ങൾക്ക് ചെയ്യാം. മനസ്സിലല്ലേ? 2012 സോൾവ് ചെയ്തിട്ടുള്ള പ്രോബ്ലംസ് ഞാൻ നിങ്ങൾക്ക് നമ്മുടെ ലിൻവേഴ്സിൽ ഷെയർ ചെയ്തിട്ടുണ്ട്, അതൊന്ന് നോക്കാം. സോ അതിൽ നമ്മുടെ ഇമ്പോർട്ടന്റ് ആയിട്ടുള്ള പേജസ് നിങ്ങൾ നോക്കിയാൽ തന്നെ മനസ്സിലാവും. സോ അതിൽ ഡിഫറെന്റ് പ്ലേറ്റ്സ് കാണാൻ വേണ്ടി പറ്റും. ഡിഫറെന്റ് പ്ലേറ്റ്സ് ഫോർ ഫൈൻഡിങ് ഔട്ട് ദ ട്രാഫിക് വോളിയം. ഓക്കെ, നമുക്ക് ട്രാഫിക് വോളിയം അല്ല, നമ്മുടെ പേയ്മെന്റ് തിക്നെസ്. ഓക്കെ, പേയ്മെന്റ് തിക്നെസ് കണ്ടുപിടിക്കാനുള്ള ഗ്രാഫ്സ് അതിലും ഉണ്ട്. നമ്മൾ 2001 കാണിച്ചിട്ടുള്ള സെയിം ഗ്രാഫ്സ് തന്നെയാണ്. സോ നമുക്ക് എന്ത് ചെയ്യാൻ വേണ്ടി പറ്റും? അത് യൂസ് ചെയ്യാൻ വേണ്ടി പറ്റും. അത് യൂസ് ചെയ്യുന്നത് സാധാരണ ഇന്റർപോളേഷൻ മെത്തേഡിൽ തന്നെയാണ്. നിങ്ങൾക്കത് നോക്കിക്കഴിഞ്ഞാൽ തന്നെ മനസ്സിലാവും അത് എങ്ങനെയാണ് ചെയ്യുക. നിങ്ങൾ ജസ്റ്റ് അതിലുള്ള CSA വാല്യൂ ഒരു എക്സ് ആക്സിസിൽ തന്നിട്ടുണ്ടാവും. പിന്നെ ഡിഫറെന്റ് CBR വാല്യൂസിന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള ഡിഫറെന്റ് ബാർ ചാർട്ടുകൾ കാണാൻ വേണ്ടി പറ്റും. മനസ്സിലായില്ലേ? നിങ്ങൾക്കിപ്പോ CBR വാല്യൂ ഫോർ എക്സാമ്പിൾ ഒരു 8 കിട്ടിയെന്ന് നോക്കാം. അപ്പൊ നിങ്ങൾ എന്ത് ചെയ്യാം? അതിൽ 8ന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള ബാർ സെലക്ട് ചെയ്യാം. മനസ്സിലായില്ലേ? എന്നിട്ട് നിങ്ങൾ എന്ത് ചെയ്യാം? ഈ 8ന്റെ ബാറിൽ നിങ്ങൾക്ക് കുറെ പേയ്മെന്റ് തിക്നെസ്സസ് കിട്ടിയിട്ടുണ്ടോ? മനസ്സിലായില്ലേ? അപ്പൊ അങ്ങനെയുള്ള ഓക്കെ അപ്പൊ നിങ്ങൾ എന്ത് ചെയ്യുക? അങ്ങനെയുള്ള 2 ബാറുകൾ എടുക്കുക. അതായത് ഫോർ എക്സാമ്പിൾ നിങ്ങൾക്ക് ഡയറക്റ്റ് അതിൽ തന്നിട്ടുള്ള ബാർ തന്നെ കിട്ടണമെന്നില്ല. ഓക്കെ, തൊട്ട് അപ്പുറത്തും ഇപ്പുറത്തുള്ള വാല്യൂസ് വെച്ചിട്ടായിരിക്കും നിങ്ങൾക്ക് കിട്ടാം. മനസ്സിലായില്ലേ? അപ്പൊ നിങ്ങൾക്ക് കിട്ടിയ വാല്യൂവിന്റെ തൊട്ട് മുമ്പുള്ളതും തൊട്ട് പുറകിലുള്ളത് 2 വാല്യൂസ് എടുക്കാം. അപ്പൊ നിങ്ങൾക്ക് രണ്ട് ബാറുകൾ കിട്ടും ഒരേ ചാർട്ടിലുള്ള, മനസ്സിലായില്ലേ? അപ്പൊ അത് രണ്ടിലെ വാല്യൂസ് എടുത്ത് എഴുതാം. എന്നിട്ട് അതിന്റെ പോയിന്റ്സ് ഒന്ന് ഗ്രാഫിലേക്ക് വരയ്ക്കുക. ഒരു ഗ്രാഫ് ഉണ്ടാക്കിയെടുക്കുക ചെറിയ 2 കോർഡിനേറ്റ്സ് ഉള്ള. എന്നിട്ട് എന്ത് ചെയ്യുക, അതിന്റെ ഇടയിൽ നിങ്ങളുടെ റിക്വയർഡ് CBR വാല്യൂ, അത് വരുന്ന സ്ഥലത്ത് വരുന്ന പേയ്മെന്റ് ലെയർ തിക്നെസ്സസ് കാൽക്കുലേറ്റ് ചെയ്യാം, ഇന്റർപോളേറ്റ് ചെയ്തിട്ട്. മനസ്സിലായല്ലോ? ആ പ്രോബ്ലം നോക്കിക്കഴിഞ്ഞാൽ നിങ്ങൾക്ക് മനസ്സിലാവും. ഡൗട്ട് വരുന്നുണ്ടെങ്കിൽ നിങ്ങൾ ഇൻഡിവിജ്വൽ ആയിട്ട് ചോദിച്ചോ. സോ വി ആർ ഡിസ്കസിങ് okay. I hope it's visible. കാണാമല്ലോ?
Yes, sir.
Okay, bitumen emulsions and modified bitumen binders. Then advantages of modified binders you can see. So it is having some superior qualities compared to normal bitumen. Okay, so the pavement materials can be tested. So the pavement material mainly composed of soil, then aggregates and a binder. Okay, so in soil we can do the following tests, just like a CBR test, plate bearing test, then direct shear test, unconfined compression test, then triaxial shear test. So all these tests can be used. So you may be knowing the tests in detail. So just like if you want to do the CBR test, then you may be knowing the steps for CBR test. So here you have to make a mold first. So that mold should be having the following dimensions, just like a 150 mm diameter and a 175 mm height. And we should place that specimen on the testing apparatus. Okay, so on the testing frame. Okay, at that time you will have certain extra additions, just like the collar, then base plate. Then you should put a paper in order to allow the moisture. Okay, so a filter paper should be placed, and after that you can do the loading. Okay, so first of all there should be a seating loading or a surcharge weight. So that on that seating load, the plunger will get in contact with the specimen properly. Okay, so initially it will not comes in contact with 100% surface area. Okay, due to some irregularities. Okay, so once you press it with some 2.5 kilogram, then it will come in contact with all the available surface area. Okay, after that you can apply the penetration. Okay, so you are applying the penetration and you are noting down the loads. Okay, so you will get a penetration load table. Okay, from that table you can formulate a graph. Okay, so we have already drawn the graph, and from that graph you can see various points, and from that point you have to select the points, load points corresponding to 2.5 mm penetration and the load point corresponding to 5 mm penetration. Okay, and here Okay, it will be like this. So you will have the graph like this, and here you can refer to 2.5 and 5. Okay, so you will get the loads here, and you can divide that load corresponding to 2.5 mm penetration divided by 1370. It will give you the CBR value corresponding to 2.5 mm penetration, and if you want the CBR value corresponding to 5 mm penetration, then you have to divide load corresponding to 5 mm penetration, that means this load. Okay, that load divided by 2055 kilogram. Okay, this should be in kilogram, so you can multiply it with 100, so that you will get two CBR values, and this value will be greater value, so you can take it as the CBR value, and if you find this value as greater value, then you have to redo the test. Okay, that's all about this CBR test. So the procedure you can study from the class note. Okay, so in this procedure you have to place the specimen and apply the load and note down the penetration versus load. So the observation, so the curve can be, we have already discussed it, the curve can be like this. Or if the curve is like this, then you can take the curve directly, and if the curve is like this, then you have to draw the tangent with the maximum slope, and you can take it as the origin. Okay, from here you can take the points. So earlier it was the origin, and now it should be the origin, and you have to shift the origin right side. So that is what you should do. And now it's a plate bearing test. In plate bearing test, you can see you are finding out the strength of subgrade soil. Okay, so here you have to have a plate bearing apparatus which is having a disc, and on top of that you can have the loads, into various quantity. Okay, so that loads can be directly provided, you provided using a jack system. Okay, so once you place the specimen, once you place the load providing equipment on the top of the soil, so you can directly go to the soil and put the device. Okay, so here you can apply the loading, so that it will go directly to the soil. Okay, so here you can draw the graphs here also. So load versus penetration, it will be like this. Okay, so here also you can have the same procedure, just like you can find out it can be taken as penetration or settlement. Okay, so you can find the K value. K value means modulus of subgrade reaction. Okay, so the K value or modulus of subgrade reaction can be taken as the load corresponding to 0.125 mm penetration. Okay, 0.125 mm penetration. The load corresponding to 0.125 mm penetration can be taken from here, 0.125. It is known as K value. And why we are using this K value? So there is an equation, Westergaard's equation. Okay, so based on Westergaard's equation, if you want to calculate the wheel load stress, then you should know the K value. Okay, so using this K value, we can substitute it in the Westergaard equation. And Westergaard equation, it is given in the class note. You can directly substitute the K value, or in exam if they ask it as a problem, then if they are given if they have given the penetration and load value, that means the displacement and load value, then what you should do? You have to draw the graph and you have to take the value corresponding to 0.125. Okay, if you take the value corresponding to 0.125, then you will get directly the k value, and you can put this k value in the equation of Westergaard. Okay, Westergaard's equation, you will have a parameter k, and you have to put that value here, and you will get the wheel load stress. Okay, so in that way you can calculate the wheel load stress, and you can find out the thickness. So here a seating load of 0.07 kilogram we have to apply first. Okay, and that way usually it's a 75 centimeter diameter area. Okay, so that way area will be having 75 centimeter diameter, and here you can apply 320 kilogram. Okay, once you apply 320 kilogram, then it will be 0.07 kilogram per centimeter square. So this load should cause 0.25 mm average settlement. Okay, so there should be 0.25 mm per minute. Okay, in that way the loading should continue. So you will get various points, and you can draw the graph. Once it is reached 1.75 millimeter, okay, once it's reached 1.75 millimeter, then you can stop the loading. Okay, then you can stop the loading and take down the points. So that's all about the plate bearing test. Okay, after that, this is the analysis of the test. Okay, then you're having tests on aggregates. Okay, in tests on soil, you can see various tests that you have already studied in the geotechnical engineering, just like the direct shear test. Then you're having the unconfined compression, then confined compression, then triaxial shear test. Okay, so all these tests are almost the same, not almost same, but exactly same. So here we are varying the moisture content and varying the time at which the drainage occurs. That means the drainage can be occurred suddenly or very slowly. So based on the allowance of the drainage, we can have various names, but the procedure will be the same. Just we have to take a sample of soil and apply shear. So once the shear failure occurs, you have to note down the load. You have to note down the load at which shear failure occurs. That's all about the procedure. You can conduct either in the box shear apparatus. If it's a box shear apparatus, then it is the direct shear test. Okay, and if you're testing in a cell, that means we can put the soil specimen in a cell, and you can apply cell pressure and deviator stress. Okay, so at that time it become confined, unconfined compressive stress. Okay, so in that way no, we can conduct various cu test, cc test. Okay, in that way various drainage conditions can be varied, and the test will also get varied. Okay, but everywhere you are finding out the shear strength of the soil only. And what about the aggregate testing? So in aggregate testing, you have already studied in the lab. Okay, so here we are having Los Angeles abrasion. The abrasion test is used in order to find out the hardness of the aggregate. Okay, so it is the property to resist wear and tear. Okay, or abrasion. So here we can use either Los Angeles abrasion test, then Dowry abrasion test, double abrasion test. All these tests can be used, but in our lab we are performing Los Angeles abrasion test. Okay, in Los Angeles abrasion test we are doing simply we are grading that aggregate. Okay, first the aggregate should be graded based on a table which is given in the class note. Okay, and once you grade it, you can decide the charge. That means some abrasive charges should be there in the form of metallic spheres. Okay, you have to put that metallic spheres plus this weighed aggregates. Okay, first of all you have to weigh the aggregate, then you have to put it in the drum, and that drum is having certain measurements just like this. Okay, so once you put it in the drum, you can rotate it. Okay, so if you have rotated, and you can take it out, and once you take it out, definitely it will be powdered. Okay, so here all these are having measurements, just like you can take some 5 to 10 kilograms of aggregate, and after that you have to rotate the drum with 30 to 33 revolutions per minute. Okay, 30 to 33 rotations per minute, and there should be number of aggregates, and the number of revolutions can be about some 500 to 1000. Okay, So that depends on the grading of the specimen. Okay, so after that you have to take it out and you have to sieve it through a ISU of 1.7 millimeter. Okay, and you have to take the fines passing through the 1.7 mm ISU. Okay, the fines passing through the 1.7 mm ISU is taken and weighed. Okay, and the percentage weight can be expressed in the form of Los Angeles abrasion value. That means the weight of the fines passing through the 1.7 mm ISU divided by the initial weight. Okay, into 100 will give you the Los Angeles abrasion test value in percentage. Okay, and in class note it's given properly. All the tests are given in class note. Okay, so after that you can have the aggregate crushing value test, and you are having aggregate impact value test too. Okay, this aggregate crushing and aggregate impact value test are almost the same, only the style of load application differs. Okay, so in crushing value test we are slowly applying the load, but in this impact value test we are providing it as an impact load. Okay, in both the cases the weight of aggregate should be noted at the beginning, and after that, after the application of load, you have to again take the powdered aggregates and make it to pass into an ISU of 2.36 mm diameter. Okay, so you have to collect the fines obtained or passed through the 2.36 mm ISU, and you have to weight it. Okay, so the weight of aggregate passing through 2.36 mm ISU divided by the initial weight will give you the crushing value or the impact value of the aggregate. Okay, so the procedure will be the same, only the apparatus and the type of loading will change. Okay, we will discuss in detail regarding the tests on bitumen in the following classes. Okay, give me the attendances. Okay, wait. Akshay, Akshaya, Abhirami, Adas, Agas, Akshaya, Anaga, Anjusha, Anupama, Arya, Asanno, Asanno. Okay, Adira, Aduna, Danish, Danya, yes, Sahala, Sarna, Tansila, Govan, Jairam, Joshua, Joshua present. Yes, Govan present. Joshua present now. Yes. Okay, present. Then Muhammad, Muhammad Ashraf, Sijin, Rachel, Sandra, Sandra, Shafna, Samjas, Sri Lakshmi, Shreya, Prabhagat, Usman, Vibilesh, Vibinjak, Vismaya. Okay. ഓക്കെ, നിങ്ങൾ ക്ലാസ് നോട്ട് നോക്കി ടെസ്റ്റുകൾ പഠിക്കുക, അതിൽ ഇക്വേഷൻസ് പഠിക്കുക, ഫിഗർ പഠിക്കുക, അപ്പാരറ്റസ് പഠിക്കുക, പ്രൊസീജിയർ, പ്രിൻസിപ്പിൾ. ഓക്കെ, എല്ലാ ടെസ്റ്റിൻ്റെയും. പിന്നെ മെറ്റീരിയൽ ക്വാളിറ്റി ഞാൻ നിങ്ങൾക്ക് സ്ലൈഡ് ഷെയർ ചെയ്ത് തരാം. നമ്മൾ സ്ലൈഡ് വെറുതെ കണ്ടന്റ് വായിച്ച സമയം കളയേണ്ട ആവശ്യമില്ല. എക്സ്ട്രാ പോയിന്റ്സ് ഞാൻ സ്ലൈഡിൽ ആഡ് ചെയ്തിട്ട് നിങ്ങൾക്ക് ഷെയർ ചെയ്ത് തരാം. അതിൽ അങ്ങനെയാണെങ്കിൽ നമുക്ക് നെക്സ്റ്റ് ക്ലാസ് തൊട്ട് പുതിയ മോഡ്യൂൾ സ്റ്റാർട്ട് ചെയ്യാം. പിന്നെ നിങ്ങൾ യൂണിവേഴ്സിറ്റി